Welcome to our introductory algebra review for pre-calculus. I'd like to start by working with graphing linear equations. So let's begin by talking about what forms of linear equations we have. The first form that most of you probably are familiar with is y equals mx plus b, but that's not the formal name for this. It is good. We're going to call that the slope-intercept form. And the reason we call it slope-intercept is because in this equation, m refers to the slope, and the b on the end refers to the y-intercept. So for example, if I were given y is equal to 2/3 x minus 4, I could graph that by simply finding the y-intercept of -4, plotting that first, and then applying the slope. And slope is rise over run. So in this case, I'd rise 2, 1, 2, and run 3, 1, 2, 3, giving me a second point. If I rose 2 again, 1, 2, 3, those 3 points would all be collinear, allowing me to model the graphical solution for this equation. The second form of linear equations is ax plus by equals c. This is called the standard form. And it's less helpful because you don't actually see the slope, you don't see the y-intercept, but there is a way to reasonably use this for graphing. For example, if we had 2x plus 4y equals 12, how many points does it take to graph? Minimum for a line. 2. If you have 2 good points, you can graph a line. Well, I can find the x-intercept and the y-intercept for this equation really easily in a standard form. What do we know about every single x-intercept? Every point along the x-axis shares what y value? Good, 0. So if I take this value of 0 for y and plug it in for y here, 4 times 0 is 0, that part just goes away. If 2x equals 12, what's x? So when y is 0, x has to be 6. That gives me my x-intercept. Similarly, for the y-intercept, every single y-intercept has what value for x? 0, which means if I plug in 0 for x, that goes away and I'm left with 4y equals 12, which means the y-intercept is, divide by 4, 3. 0, 3. And with those 2 points, my y-intercept, my x-intercept, I could graph this equation. The third and final form of a linear equation is what's called the point slope. And the structure of that is y minus y1 equals m times x minus x1, where m is the slope and x1 comma y1 is some point. So for example, if I had y minus 6 equals 2/3 x plus 2, let's say x plus 3. I could look at this and say, okay, I know my slope can be pulled out directly as 2/3. And I know that these two components will give me some point, some coordinate that lies on the plane. In this case, it would be whatever's being subtracted from x. So that would be -3. And whatever's being subtracted from y. So that'd be 6. I'm going to plot my point first. -3, 6. And then I'm applying a slope of up 2 over 3. Or down 2 to the left 3. And that would be my line. Any questions on graphing linear equations? from a given equation. Okay. Second stage. What if you're given information and you're supposed to create the equation? So for example, what if you have a coordinate 0, 5 and a slope of 1/3? Yep, y equals mx plus b, and my m is just my slope, and my b is my y-intercept. Well, this one was particularly easy because I gave you exactly the slope and the intercept. What if I had given you a slope and a point that's not an intercept? Well, we could do it the same way. Y equals 1/2 x plus b. We don't know what b is this time, but we do know that 2 and 7 make an ordered pair such that x and y both satisfy this. So if I plug in a y value of 7 and an x value of 2, I can solve for b. 7 equals 1 plus b, subtract 1, 6 is equal to b. Therefore, my equation is y equals 1/2 x plus 6. Now, I've written this equation in what form? Use the words. Good. Slope, intercept. If I asked you to write this in standard form, how would you do that? You do the same process, but now we have to convert this. Is this in standard form? No, standard form says ax plus by equals c. So our y value is in the correct place relative to the equal sign. Our c for constant is in the correct place, but this is in the wrong place. So I need to move it to the other side by subtracting. Now I've got 1/2 x plus y equals 6. Is that now in standard form? Not quite. Bit of a trick. Standard form requires that a, b, and c are all whole numbers, not fractions.
Wait, so that means it's multiplied such by -2 with -1/2 because of the negatives. Because that
You could divide it by -1/2. In this case, I'd probably multiply by -2. That turns this into a positive 1x minus 2y equals -12. And that's a good form of the standard equation. There's an argument whether I could have multiplied by 2 and left the lead coefficient negative. Typically, a is a positive integer to fit in standard form.
Wait, what does it mean when it says x-intercept is something with no other number? Like x-intercept equals -2. Like
The last piece for linear equations is to talk about parallel and perpendicular. If I know that I've got a coordinate of, for example, 0, 5, we'll make this easy again. In the first case, I want my slope to be parallel to another line, to a line like y is equal to 3/7 x minus 6. What I'm missing is my slope. I've got a coordinate. In fact, it's the intercept. How do I find the slope out of this one that's parallel? Well, parallel means the same slope. So if this slope is 3/7, then the slope I'm looking for is the same slope, 3/7. So I could write that as y equals 3/7 x plus 5. On the other hand, if I'm told that the slope is supposed to be perpendicular to y equals 3/7 x minus 6, what's true about the slope that's perpendicular to 3/7? Good. Negative reciprocal. So that would be -7/3. So in this case, that would be y is equal to -7/3 x. And again, because that's the y-intercept, we'd say plus 5. Okay, that's page 1 and first half of page 2. The next topic for us is factoring. What does factor mean? What's the opposite of multiplication? Division. But isn't factoring like unmultiplying? It's like disassembling multiplication. So it's a weird concept. There's a couple of ways we should look at it. One is what's called the greatest common factor. If I have, for example, 5x squared minus 20x, this is a binomial, two terms separated by addition or subtraction. And if I wanted to factor out the greatest common factor, what I'd really do is break each of these terms into their prime factorization components. So that would be like 5 times x minus 2 times 5 times x. And I'd look for what's common to each of these terms. What's common to both terms? 5 and x. Since that's the greatest common factor, I'd pull that out front. And everything that remains, in this case, x minus 4, goes inside. This is now a factored binomial. A second type of factoring we're going to deal with is quadratics. And let's start with trinomials. For example, if I've got x squared minus 8x plus 15. At this point in your careers, this one should probably jump out at you. But let's do the whole process just to make sure. We use a diamond or an X. And in the top, we put the product of the first and the last term, positive 15x. And in the bottom, x squared, excuse me. And in the bottom, we put the middle term. We're looking for what numbers multiply together to make the top, and at the same time add together to make a -8. What would that be in this case? -5x and -3x. Now, some of you have learned a shortcut for this, and this is great. For this specific problem, you could actually just use the -5 and -3 and call it x minus 5 and x minus 3. That'd be great. However, I'm going to show you the process that we can use not only for this, but also when the lead coefficient's a different number, and it will come up for other things for us as well. We're going to do what's called factor by grouping. I'm going to take the same equation. I'm going to repeat that x squared. I'm going to repeat the 15, but I'm going to break this x minus 8 up into a certain way, a particular way. I'm going to break it up into these two parts. So I'm going to call it minus 5x minus 3x. Still equivalent to this, but it's broken up strategically like this. Now I'm going to redo the same thing I did here, greatest common factor, for these two terms grouped and these two terms grouped. For this one, I'm going to say, well, this is x, and this is 5 and x. So I got x being common, and what's left is x minus 5. For this one, I've got -1 times 3 times x plus 3 times 5. What's common to these two? Looks like a 3. But if I do that and just take out the 3, notice that I get x, well, -x plus 5. I need this piece here to be exactly the same as this one. So I'm not going to factor a 3 out. I'm going to factor a -3 out. Leaving a positive x here, that's what I'm expecting. And -3 times what gives me a positive 15? -5. And that's what I was looking for. I want to make sure that these two components, x minus 5, x minus 5, are the same. Once they are, I'm going to do exactly the same thing I did up here. Remember where we looked for something that was common to both parts? In this case, it was 5x, because they're multiplied by x and multiplied by 4. Down here, what's common to both terms? X minus 5 is common in both terms. So I pull that out front, and what's left is x minus 3. And that's my fully factored form. This works as well when you have a lead coefficient, and the other method, the little cheat method, doesn't work as well. We do have some special cases like difference of squares. When I've got x squared minus 25. Remember how that factors? Do you agree that this is a difference, subtraction, of squares? X squared is a perfect squared. 25 is a perfect square. What is the square root of x squared? X. What's the square root of 25? And when it's a difference of squares, you're going to have one positive and one negative. X minus 5, x plus 5. This idea, difference of squares, is super important in this class. We're going to use this a lot. Get friendly with difference of squares. In fact, we're going to do it in a way that's a little interesting. Can I apply the difference of squares concept to factor x squared minus 5? We're tempted to say no because 5 is not a perfect square. But let's pretend it is. What would go in the first slots here? Good, x and x. And for signs, we'd say minus and plus. And what goes here? Square root of 5. Doesn't that work? It does. There'll be times when you want that answer. There'll be times when you don't want to go that far. You want to leave it like this. But you should recognize this relationship. In fact, we can even take it one step further. Can I treat x squared plus 9 as a difference of squares? But it's not a difference. It's a sum of squares. So if I had like a minus and a plus, it wouldn't give me a negative answer on the end. But let's treat it as a difference of squares. X squared minus what? Good, negative 9. So that means when I want to factor it, I'd put an x here and an x here, minus plus. What goes here? Almost. Do we agree it's the square root of negative 9?
No, one's positive.
No, we've got a negative here and a positive here, but in both these places, this is always exactly the same. It's the square root of this number. It's the square root of this number. What is the square root of negative 9? When you take the square root of a negative number, what's this? Yes, imaginary. What's the square root of negative 1? I. So I can treat the square root of negative 9 as the square root of negative 1 times the square root of 9, which is I times 3. So I could factor this completely as x minus 3i, x plus 3i. Now, I don't think you guys have done this in advanced algebra, so I'm giving you a little preview of where we're going with this, but the difference of squares you should know coming in here. Okay. You're also going to be dealing with something called the difference of cubes. For instance, if I have x cubed minus 125. It's another special case. Any guesses? This is one of those things that you probably have to just remember. We know that the difference of cubes has a formula, and the first part of that is a minus b. So what's going to go in this first part? X minus 5. Now, I always forget this, the second part of this formula, but that's okay. If I know that x times something is going to make x cubed, what will I get here? x squared. And if I know that -5 times something is going to give me -125, what goes here? Plus 25, because -5 times 25 makes -125. The problem is this middle term. And if I were to distribute this 25 across this x, I'd get a positive 25x. But if I do this -5 times x squared, I'm going to get a -5x. I'm going to get 5x squared. I'm going to get these middle terms in here. If I were to put a 5x here, now when I multiply -5 times 5x, I get -25x. That's going to offset. And if I do x times 5x, I'm going to get a positive 5x squared, which is going to offset our -5x squared. So this is the formula for difference of cubes. We have a similar environment for the sum of cubes. Let's make sure that works. So this will give us a cubed. It'll give us an a squared b positive and an a squared b negative. It'll give us a positive ab squared. It'll give us a negative ab squared. Yep, that's right. Okay. How do things change when I'm given something like -2 -2 get 5 and 3 is 15 is 45. If this is set equal to 0, how does that change the problem? Now the idea of factoring is a tool to accomplish a mission. We're trying to get at the end that x equals something. What would be my first step to factor this? Greatest common factor, really good. So I'll pull out the 3. X squared minus 2x minus 15. And then I do my diamond. And again, I think in pre-calc, you guys should be getting close to doing some of these simpler ones directly. Anyone see this one directly? Good. X minus 5x plus 3 equals 0. Now, this next step is another super important part in pre-calculus. How do I get from this to what x is equal to? 0 product property. 0 product property. It says that if I have 3 numbers multiplied together to equal 0, specifically 0, one of them must be 0. So maybe 3 is equal to 0. Well, no, that's not true. Maybe x minus 5 is equal to 0, in which case x equals 5. Or maybe x plus 3 is equal to 0, in which case x equals -3. Those are my 2 solutions. So when it says solve, you use whatever techniques you need, and then 0 product property to find the answers. The other side of factoring is multiplying. And the official name here would be multiply polynomials. And often they'll just call it FOIL. But FOIL is really just when you multiply 2 binomials. You do the first terms, the outer terms, the inner terms, and the last terms. First, outer, inner, last. But in multiplying polynomials, really what we want to be looking at is, for example, x minus 3 times x squared plus 5x plus 2. I want to do the distributive property repeatedly. So first I'll do it with my x and distribute it across each term. X times x squared is x cubed. X times plus 5x is 5x squared. X times plus 2 is plus 2x. And then I do the second part. Now I've got to distribute the negative 3 across each of the three terms. Negative 3x squared, negative 15x minus 6. And there's one more step for simplification here. I only have one x cubed, so that part's easy. But there's two x squareds involved, a 5x squared and a negative 3. The net of those is 2x squared. And then I've got a couple of x terms. Positive 2 and a negative 15 is negative 13x. And I'll have one constant. And that's the process of multiplying polynomials. By doing each of these in turn to distribute through, you can multiply a trinomial times a trinomial as many sizes as you want. Okay. Next piece is radicals. Taking a radical of a whole number that is a perfect square is super easy. What's the square root of 36? 6. Good. Little pro tip off to the side. What if instead of the problem being given to you like this, you were given something like x squared equals 36? Square root both sides. Is that right? Good. There has to be a plus or minus. When you break out this tool, you put in the plus or minus. The answer comes out to be two different values, plus 6 and minus 6, positive and negative. When it's given to you like this, it's showing you whether it's positive or negative to begin with. Therefore, your answer ends up being that same sign. If we wanted you to get the negative, we would have done this, in which case you'd give me the negative answer. Right? If I give you the number 5, is that positive or negative? Positive. If I give you 5 and I don't tell you anything else, you assume it's positive. So if I give you a square root with no symbol on front, that means I want the positive one. But if you introduce the square root symbol, give me both positive and negatives. Okay. Now, what this really means when I say square root of 36 equals 6 is I'm saying what number times itself equals 36. An easy way to see that would be to factor it up and recognize that these two numbers both show up inside. Therefore, they can come out as a single 6. I have a slightly inappropriate description for this that my geometry students have heard. This is what resonates for me. I'm going to share it with you. Back in the 70s, they used to have these things called singles bars. And I picture this as a singles bar. Here's the doorway coming in. And inside that singles bar are all these people who are trying to find love. Now, 50 is an amalgamation of a bunch of things. In there, we've got a 5 and a 2 and a 5. We've got 2 x's and we've got 5 y's. But the whole purpose of this club is for people to find their perfect partner. So who's pairing up in here? The 5s do. And once they find each other, are they going to stay in that loud, noisy, smoke-filled bar? No, they're leaving. And when they go out, they're one of those sickeningly sweet couples that are like arm in arm, and they may as well be a single person. They come out as a 5. Who else gets to leave? The X's get to come out, and when they come out, they're one of those sickeningly sweet. Good. Here's one Y. Here's another Y. So we take out a Y squared. Who's left inside looking for love? 2. No X's. We used all those up, but there is one Y. So this is the simplification of a radical. What I like about this example or analogy is that it also works when there's a sign out front that says this is for thruples. So now I'm going to still see who's inside. This is going to be 2 times 2 times 2 times 2 times 2, and there's going to be 5 x's. Who finds their partners? 3 of the 2's get to create a thruple. And when they come out, they're a single 2. These 3 x's make a thruple. So they come out as a single thruple. And the sign's still on the door, and who's left on the inside? 4x squared. Yes. I did. The 3 tells me what kind of club it is. You're looking for thruples. Okay. All right. When dealing with radicals, let's say that I have 2 square root of 5 plus 7 square root of 20. Can I combine those terms? Radicals are kind of like fractions. You know how in fractions, you can add fractions only if they have a common denominator, but you can multiply any fractions? If I had 2 root 5 times 7 root 20, that's easy. The outsides multiply together and the insides multiply together, and then I could simplify. But adding is a little bit different. You have to have like the common denominator. It has to be the common radicand. So in this case, I have to simplify root 20 first. Inside that club is 2 times 2 times 5. The 2 gets to pair up and come outside. So it's 7 times 2 with a 5 stuck inside. So this is 14 root 5. And oh, look, I have 2 roots of 5 plus 14 more of the same thing, 14 roots of 5. What does that become? 16 roots of 5. All right, going back to fractions for a second. Like we said, fractions are easy to multiply, harder to add. If I have, for example, 3/5 times 10/7, and I multiply these fractions, they create one big fraction where the top is the result of these multiplied together and the bottom is the result of these multiplied together. But rather than call this 30 over 35, we're going to want to reduce our answer. Easiest way to think about that is to factor the top and factor the bottom. And anytime we find a number that's on top and on bottom, we can think about that as 5 over 5 times 3 times 2 over 7. In other words, if we can take 2 fractions multiplied to make a long, bigger fraction, we can take a long, bigger fraction and break it up into 2 fractions. This is just 1, so that doesn't affect things. That's why we can cancel those. The answer here would be 6/7. The same holds true if we have something like x squared minus 9 over x plus 2 times 3x plus 6 over x minus 3. I would consider this as one big fraction, and I'd want to factor it out. So how does x squared minus 9 factor? Good. X plus 3, x minus 3. Excellent. How does 3x plus 6 factor? 3 times x plus 2. On the bottom, I've got an x plus 2, got an x minus 3, and because these are all multiplied together, I can do like I did up here. X plus 2 cancels with x plus 2. X minus 3 cancels with x minus 3. So my answer is this. Usually we'd write it like this. What about division of fractions?
What?
Hold on. Say it louder, please. Good. Copy, change, flip, or keep, change, flip. So 3/5 times 10/8. And then we do the same process we did up here. I see that 5 and 10 have something in common. So 3 times 2, 2 and 8 have something in common also. So this is 3/4. Would this change if it had been written like this? Or is that the same problem? It's exactly the same problem. You'll see the last couple problems on the packet for today have it written like this, except they're polynomials, algebraic expressions rather than just numbers. Now, the moment I wrote this 8/10, did any of you wince? Like, hey, that's not the right way to write that. Do you recognize that there's a factor that can come out of both? You should reduce that. I love that your brains see that. You need that. I'm going to ask that you continue with that prospect when we talk about radicals in fractions. You should also look at something like this and wince at the idea that there's a radical in the denominator. That just doesn't belong there. To be simplified. So how do I get rid of it? Charlotte?
You multiply by such by root 3, that says over 3.
Okay. A lot of people, you're right, a lot of people would make a mistake and say, I'm going to square it because I want to get rid of the square root. But let's make sure for a second, if I took 1/2 and squared it, what would it equal? 1/4. Those are not the same value. So squaring a fraction doesn't leave it alone, doesn't just change it, simplify it. Instead, what I'm going to do is I'm going to multiply by something to get rid of this denominator, which is going to be square root of 3. But I'm not allowed to just multiply it by a number randomly. Instead, I have to multiply it by a version of giant 1, something over itself. In this case, that would give me root 15. And down on the bottom, I've got 3 times 3. Well, if I've got 3 times 3, then 3's meet up. And they come outside as just a regular 3. Now, can I take this 3 and this 15 and reduce that? I cannot. Good. What's inside the club goes on inside the club. What's outside the club stays outside the club. They don't mix. So this is the final answer there. One more piece like that.
But is it okay if I do plus minus they wanted 2 answers for each problem?
I'm going to address that in just a second. Let me finish up here, okay? What if I have this? 3 over 2 plus I. Is anyone wincing? Because what's I? Square root of -1. So I've got a square root in the bottom here. I got to clear that off. But what do I multiply by to clear off this square root? Some people might think I should just multiply by I over I. But that would make it 3i, and this would distribute. Give me 2i plus I squared. I didn't clean it up. The I squared is great. What's I squared? 1. Close. -1. Good. But 2i is a problem again. I just made the problem different, but still problematic. So you don't multiply by I over I. Instead, you multiply by something that's a lot like that difference of squares. You multiply it by the conjugate. What's the conjugate of 2 plus I? 2 minus I. And now on top, I'll distribute. On the bottom, this is the difference of squares. 2 times 2 is 4. -2i and a positive 2i, the middle term cancels out. Minus I squared. So that's 6 minus 3i over 4 minus a -1. That adds then. So it's 6/5 minus 3/5 I. Okay, I think that gives you a foundational structure from which you should all be able to do this algebra review. Your homework is to complete all the even numbers, show your work, be careful about what you're doing. Finish this up by Monday.